what I put right here is just a summary of what the signs are in the different quadrants, but you should be pretty familiar with that. Here, the cosine and sine are both positive. Here it's a negative cosine, positive sine. Here they're both negative, and here the cosine's positive, the sine is negative. And so when you look at the reciprocals, you should be able to see those correspond to the sines. And then when you look at the tangent and cotangent, you should be able to see sine over cosine. You can see that they're positives here, and then they're negatives, opposite signs here. So it's not something where you need to memorize this. You should be able to recreate it pretty easily. But the whole idea is when you're working with some of these problems where you're identifying what the trig ratios are of if you're given one ratio and you're told what its quadrant is, you should be able to use this to identify those. And in addition to this, you're going to use Pythagorean theorem. Right? And here's how you can set that up to find it. Okay? So if you know that the sine of an angle is 12 over 13, and the angle's in quadrant 1, what you can do is you can just sketch a triangle in quadrant 1, or whatever quadrant they give to you. Okay? Assign your angle to be theta. And now your option is you can either treat this as a unit circle, or you can treat it like you would a Pythagorean theorem in a right triangle. I would encourage you to treat it like a right triangle. And the reason for that is here, if you take sine is SOHCAHTOA, right? Use the right triangle properties. Sine is opposite 12 over hypotenuse 13. And by using that, you can then use Pythagorean theorem to find what the missing side is. If you recognize this is a 5, 12, 13 common triple, you can find that. Otherwise, you'll need to use Pythagorean theorem and say a squared plus 12 squared is equal to 13 squared and solve for a. Again, in doing that, you would find that your a value is 5 here. Okay? And so once you get this set up, what you would do is, and it's not apparent in this one because we're in quadrant 1, but the x and the y have to have the correct signs. Okay? So this is positive, this is positive. Okay? If it was in quadrant 2 or quadrant 3 or quadrant 4, you'd have either negative signs or negative cosines based on the quadrants. Okay? But here we have just those measurements. And once we have that, the hypotenuse is always going to be positive on these right triangles when you're using the properties of Pythagorean theorem. And so you can now set up and find the remaining trig ratios. So tangent is opposite over adjacent. Okay? Or let's do the other main ratio. Cosine is adjacent over hypotenuse. And once you get the three main ratio or the main trig ratios, you can then do their reciprocal ones. So the cotangent is the reciprocal. Here, the cosecant is the reciprocal of secant, so 13 over 5. And then the cosecant is the reciprocal here, 13 over 12. And so